All right, in this video, we're going to be going through the 7.3b class notes. If you watched the first video, example 1, in detail, then you saw me slowly and painfully work out every single row operation, moving from this augmented matrix to this, to this, to this, to this, until we got to the row echelon form, and then kind of doing back substitution, working to zero out above, till I got into reduced row echelon form, and we found the solutions to that system. And the last video, I ended off by saying, all right, so look at this system and try to solve it. And then I went ahead and tried to solve it. And lo and behold, you can get a decent amount of work done before it just becomes, I'm going to have to deal with a whole bunch of scary looking fractions that I'd rather not deal with if I can avoid it. In the end, they all work out nicely, but in this class, at this level, not something I'd expect you to do by hand. So what do? Go to your calculator. So I want to show you how you would use your calculator. So in class before, we've talked about how to use our calculator to create a matrix. So what I have here is I just went ahead and I put in my augmented matrix, right? So you can see I've typed in my augmented matrix. And now if I want to put this matrix in reduced row echelon form, I'm going to come over here to menu. I'm going to choose the matrix and vector category, and then I want reduced row echelon form. Notice if I choose row echelon form, and then if I copy paste, or if I do second answer here, right, second answer, or again, I just am going to copy paste because I like being able to see it very nicely. If I do row, so we can see there's some of the fractions that are going to show up if I did row echelon form, where I've just got my ones down my diagonal and zeros. If, however, I were to just delete that, menu, no, right here, no, escape, here, menu, matrix vector, reduced row echelon form of that matrix. As you can see, it actually works out to be a pretty nice looking matrix. And that's what I have for you right here. And so let's interpret. So what does this mean? If we use our calculator, reduced row echelon form, and we get it looking like this means then, again, this stood for U, V, X, Y, and Z. These are all the coefficients, right? So equals constant, right? So I'm going to have U minus 23z equals negative 8. This is telling me v is 1. This is telling me that x minus 18z equals negative 6. This row here is telling me y plus 16z equals 5. And so solving this for u, solving for x, solving for y, basically tells me z is my free variable here. So z is the variable that can be any real number. And so the general solution to this system that we started with in example 2 is the ordered 1, 2, 3, 4, 5, the ordered quintet, where u is 23z minus 8, v is always 1, x is 18z minus 6, y is negative 16z plus 5, and z is free. Z can be any real number. All right, let's look at example 3. This one, all of the details are already in the notes for you, except I went ahead and wrote in just now the row operations that I'm doing to get from matrix to matrix. But example 3, the graph of y equals f of x equals ax cubed plus bx squared plus cx plus d, right? So it's a cubic. This cubic contains these 3 points. Now, believe it or not, those 3 points are not enough to uniquely define a single cubic, but it will define a family of cubics. So there's a whole family of functions that satisfy the condition that these 3 points are on it. So how do we use these? Kind of like what we did with a parabola. In this case, x, y, x, y, x, y, and what do we have here? Y is equal to plugging all these values in for x. If I plug negative 1 in for x, y, negative 6, is equal to negative a, because negative 1 cubed is negative 1. So negative a plus b minus c plus d. If I plug in x is 0, ooh, that's the really nice one. That basically just means d equals negative 1. So I'm going to put that in my last row of my matrix, of my augmented matrix. And then 1, 2, if I plug 1 in for x, well, that's just a plus b plus c plus d equals 2. So what you can see, I took those points, gave myself equations in a, b, c, and d, put them in an augmented matrix. From here to here, first I just swapped rows 1 and 2. So my 1, 1, 1, 1, 1, 1, 1, 1, 1, 2 is up at the top. Then I added these 2 rows. And then from here to here, I divided this row by 2, right? And then from here to here, I zeroed this guy out by multiplying this by -1 and adding up. Or no, sorry, from here to here, I zeroed this guy out first by multiplying this by -1 and adding up. So -1 and adding up there. And then zeroing this guy out gave me the equations again. If this is A, B, C, D equals, right? A plus C equals 4, B equals -1, D equals -1. And so in this case, you could choose to let C be the free variable, or you could choose to let A be the free variable. If you solved this and said A is equal to 4 minus C, then you would have had 4 minus C as your coefficient. So you could have said, or f of x is equal to 4 minus C x cubed. Again, B is always -1, so minus x squared. C would be free, so plus cx in this case. And then, again, D is always -1, where C is any real number. What's the difference between this and this? Again, the only thing that is relating is this coefficient and this coefficient they both sum up to 4. So either you're going to let A be the free variable, which is preferred because we like having a single number here in front of x cubed. Or if you solve for here, then C is your free variable. And it's the same family, even though they look slightly different. All right, let's look at a few more examples. So example 4. I'm going to only go down this far. Charlie, Ryan, and Harrison produce silver alloys of 3 types. A 22% silver alloy, a 30% silver alloy, and a 42% silver alloy. All right, they have an order to produce 80 grams of a 34% alloy, right? Well, that's not one of the ones they make. So what are they going to have to do? They're going to have to mix, right? How many grams of each of these 3 alloys should they use? If they also want to use twice as much of the 30% alloy as the 22% alloy due to inventory costs, right? So in fact, it's actually a lot cheaper if they want to use twice as much 30% alloy as the 22% alloy. So the first thing you have to do to solve this, right, give yourself some variables. Let x be the number of grams of the 22% alloy. Let y be the number of grams of the 30% alloy. Z be the number of grams of the 42% alloy. X, y, and z. All right. We have 3 variables. So to have one unique solution, we must have 3 equations to have a system with one unique solution, with any hope. So grams equation. What is it that they have to produce? They have to produce 80 grams. So if we take the number of grams here, plus the number of grams there, plus the number of grams there, they all have to add up to 80. Pretty straightforward. That's one equation, yeah? Okay, it has to be 80 grams of a 34% alloy. Well, if you do X, so this is the alloy equation, also the silver amount, right? So 80 grams, 34% of that should be pure silver. So what are we going to do? We're going to multiply, well, 0.22, because that's 22% of X grams is pure silver, plus Y, 30%, so 0.3 Y, plus 42%, 0.42 Z should equal, well, 0.34, 34% of the 80 grams that we need. So that's your alloy equation, or the actual amount of silver, right? So it's your percentages times all your grams. And then we have this last sentence here that says they want to use twice as much 30% alloy as 22% alloy. So how do I write that as an equation? I want 2 times something to equal something else. So again, what variable goes where? I want twice as much 30% alloy. So the 30% alloy was our y. So would it make sense to say I want 2 times y to equal our 22%, our x? Does that make sense? They want twice as much of the 30%. So let's give ourselves a for instance, right? Let's say they use, let's go very easy, 2 grams. 2 grams of the 30%. That should be twice as much as the 22%. So that means 1 gram of the 22%, right? So is this correct, 2 times y? No, it's actually 2 times x. So really, when you're reading this, they want twice as much as. So ignore this for a second. You want twice as much as the 22. So it should be not 2y, but 2x equals y. The amount of the 22, double it, that's the amount of the 30%. So the inventory equation is actually 2x equals y. Now, we typically don't like having our variables on opposite sides, so if we very quickly rewrite that as 2x minus y equals 0, that's our third equation. And so if you scroll down here, you can see I've put these in a slightly different order. So x plus y plus z is 80. Here I've got my 2x minus y equals 0, right? And here I've got 22.22x plus 0.3y plus 0.42z equals 0.34 times 80. Now, before I even put this into a matrix, I'd really rather not deal with decimals. So I'm going to multiply this entirely by 100. And so this is 22x plus 30y plus 42z equals 34 times 80. 34 times 80 is 2,720. So put that all into your calculator because, again, big numbers, not worth it. Actions, matrix, row reduced echelon form, put in this augmented matrix, and it will give you back exactly what your answer is going to be, right? So this means 1x. So I want 160 over 11 is about 14.545454, or exactly 14 and 6/11 grams of the 22% silver, 29 and 1/11 grams of the 30% silver, 36 and 4/11 grams of the 42% silver. That's how many grams of each alloy you should be using. Okay, so to finish up, I would like you right now to try this problem on your own, and that will finish up 7.3b. So example 5, read it. I went ahead and gave you some variables to start with, but on your own, try to set up a system of equations, try to create a matrix equation, and then use your calculator to go ahead and find the solutions. So I'm going to please pause the video now because I'm about to reveal the solutions. So pause and work on this now, please. All right, so for most problems, the hardest part is just setting up all the equations. Again, we've got 4 unknowns, so we're going to need 4 equations. The first few are kind of easy. $12 million portfolio. So however much they invest in treasury notes, in bonds, in real estate, and in the stocks should all add up to 12 because we're going to measure things in terms of millions. So if they want to earn this much interest or that much profit, well, 4% of the treasury plus 6% of the bonds plus 7% of the real estate fund plus 10% of the stock should equal $8,000 or $810,000. But what is this in millions? We'd have to divide that by a million. So it's equal to 0.81, right? So one of the things I'm going to do very quickly is, again, get rid of all of the decimals, and I'm going to turn that into 4t plus 6b plus 7r plus 10s equals just 81. T plus B plus R plus S equals 12. And so what about these other 2 equations? Again, if they invest the same amount in the highest and the lowest yield, so the 4% and 10% are the highest and lowest, that's treasury should equal stocks, so T equals S, or if you subtract S, then you're going to put that into one of your equations. And then last but not least, if they invest as much, that means an equal amount in real estate equals as the bonds and notes together, right? So real estate is equal bonds plus treasury notes together. So if I subtract R from both sides, I get T plus B minus R is 0. Grab your coefficient matrix, put that into your calculator to find the row reduced echelon form, and then your answer just kind of falls right into place. Your 2 million in treasury notes, 3 million in your bonds, 5 million in your real estate, and 2 million